Hello guys, welcome back. Myself, Assistant Professor Gaurang Prajapati from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we are going to cover the topic of the plastic design of the subject design of steel structure 8th sem civil engineering. In the previous video, we have covered the theoretical portion as well as examples regarding shape factor, then derivation using the static method and kinematic method, then analysis of the beam using the kinematic method, and in the last video I have covered the design of the beam. Okay, so now next criteria will be the frame. Okay, now so talking about the portal frame, this is the last topic of this chapter. Now we need to solve the portal frame. We need to calculate either collapse load or we can say the plastic moment, whichever has been asked in the data. So let's solve the data first of all. Just a minute. Now, example number 1. Determine the collapse load for the portal frame shown in figure. All the members have the same plastic moment of resistance. In November, it has been asked in the November 2017. Okay. So now, first of all, in case of the portal frame, the first step is to find the numbers of independent mechanism and then all the possible combined mechanism. So what we need to do, first of all, we need to calculate the numbers of independent mechanism, and based on the numbers of mechanism we will combine it. Okay, the possible. Now first of all, let's find that which point plastic hinges will be produced. Okay, plastic hinges are always produced at, we can say, fixed support, then at intermediate support and the location of the load. So first of all, as we can see, at A fixed support is there, so moment will be produced. Okay, so plastic hinges will be produced at A, then B, that is intermediate support, so B, then C, that is location of the point load, so it will produce over here also. D, that is, we can say, intermediate support, so at D. And talking about E, it is a hinge support. Okay, so at hinge support moment is never produces, so plastic hinge will not produce over there. So ultimately plastic hinges will be produced at A, B, C and D. Okay, so now numbers of possible independent mechanisms, the formula is capital N equals to small n minus r, where small n, that is this one, these 4 points. Okay, where small n, numbers of plastic hinges, that is 4. Now we need to calculate this r. Talking about r, so r stands for, just a minute, degree of redundancy, means in simple words that is SI. Okay, numbers of independent means numbers of reactions produces minus numbers of equilibrium condition. Now talking about numbers of equations produces. Okay, so first of all, fixed support, so 3 reactions will be produces, vertical, horizontal moment. While talking about hinge support, 2 reactions will be produced, that is, this one is 3, this one is 2. So we can see in the value of the capital R, 3 plus 2, that is 5, minus 3, equilibrium condition, sigma h equals to 0, sigma v equals to 0 and sigma m equals to 0. These 3 are the equilibrium conditions. Okay, so let's put down it over here, 3 plus 2 minus 3, so our answer is 2. Okay, so there are chances that r, the value of the r is 2. Now let's find this capital N. So capital N equals to small n minus r, small n is 4, r is 2, say 4 minus 2, answer is 2. So now this 2 indicates there are 2 mechanisms are possible. Say number 1, that is this one, say beam mechanism. Another, that is because of this force, that will be sway mechanism. So we have already studied the beam mechanism in the kinematic method, so let's solve the mechanism. So first of all, beam mechanism. Now what we will do in the beam mechanism, so from this frame we will simply deduct the beam from this one. So this one is our beam, say central point load at L by 2, and moment is MP. Okay, so let's do the figure. See, beam, just a minute, this one is our beam, load is W. Now mechanism, that is like this, twice theta, theta and theta, as we were doing. Now both B and C are intermediate support, so moment will be produced at B as well as at C, and at the center obviously moment will be produced, that is MP. Okay, so first of all, where plastic hinges are produced, at B, at C and at D. Okay, as you can see, moment is there, so plastic hinges will be produced at B, C and D. Now external work done, so for that one we need to derive the relation between theta. As we have already discussed in the previous examples, for the central point load both theta will be equal, Okay, so theta, there is no problem with that one. Talking about deflection, let's take any of the triangle. See, tan theta equals to this dimension, that is delta, divided by this dimension, that is L by 2. So delta by L by 2. So delta equals to L by 2 into tan theta. So tan is very small, so delta equals to L by 2 into theta. Okay, so first of all, external work done, load into deflection, W into deflection, W, deflection is L by 2 into theta, so that is W L by 2 theta. That is external work done. Talking about internal work done, so for that one, over here moment will be there as intermediate support, over here also is there, and over here at the center point also. So first, this MP into theta, that means for this one, this MP into 2 theta, that is for this one, and this MP into theta, that is for this one. Okay, so we can see total, that is 4 MP into theta. Now by the principle of the virtual work, external work done equals to internal work done. Now external work done is W into L by 2 into theta, internal is 4 MP into theta, that is this one. Theta will be cancelled, so ultimately W equals to 8 MP divided by L. So that is the solution of the beam mechanism. Now talking about frame mechanism, now just because of this force, vertical leg will be displaced by this much, say like this. So ultimately this will be our frame mechanism, fixed support, and over here hinge support. Okay, beam will be transferred from here to here at the same level, so beam will be over here. So this will be our figure. So let's do the figure first of all. See this one, this is our original figure. Okay, now this was our, just a minute, this one was our regular figure. Okay, so ultimately it will create an angle with them. Okay, first of all, this angle theta, with this angle also theta, over here with this angle theta, and with this angle also theta, like that. Okay, so as we can see, theta, 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 theta. Okay, now let's talk about the point where moment will be produced. Now one thing is for sure, our original beam was like this. At A it was fixed support, and at D it was hinge support. A, B, C and D. So simple, at A moment will be produced, so at A plastic hinge will be produced. At B and C intermediate support, so at B and C also moment will be produced. At D moment will say it is a hinge support, so moment will not produce, so over here D no moment will be there. So plastic, so ultimately plastic hinges will produce at A, at B and at C, sorry, D, whatever the point name is. Okay, A, B and D. Okay, this one is A, this one is B and this one is D. Okay, like that. So now talking about external work, the same way. See, sway means what? See, usually we need, whenever we say, just a minute. See, usually whenever we say deflection means we, for example, our central point load is there. So because of central point load, deflection will occur like this. So we are usually used to denote this one as a deflection. But this is the deflection of the horizontal beam. Similarly, the vertical legs deflection will also be there. Say, if the load is applied like this, and ultimately this frame will be bend like this, so ultimately this one will be the deflection of the vertical leg. So sway is nothing, sway is the deflection of the vertical leg. So we need to calculate this delta. So we were using the same technique before also. This delta, this one is our theta. So tan theta equals to, we can say, delta divided by this length is L. So ultimately delta equals to L into tan theta. So tan is very small, so delta equals to L into theta. Okay, so that is the value of the deflection. So external work done means this load into this deflection. Say load into deflection, deflection is L into theta. So we got this one. Okay, now talking about internal work done. So for that one, first of all, over here moment will be produces, so MP into theta. Then at B point, because of intermediate support, moment will be produces, MP into theta. And at D point, again because of intermediate point, moment will be produces, that is MP into theta. So ultimately total will be 3 MP into theta, this one. while external is this one. Now let's equal both terms. External equals to internal WL theta equals to 3m theta, 3mp theta, sorry, theta theta will be cancelled. So WC equals to 3mp divided by L, that is sway mechanism. Clear? Now as we have solved both beam and sway, so ultimately now we need to do the combined mechanism. So now in combined mechanism, what we need to do, see, firstly we have drawn this one beam mechanism, this one. Now we need to put this beam exactly on this ultimately frame. See, this is our frame, okay, frame mechanism. So let's put beam over here. So ultimately this will become our beam mechanism. Simple. Okay, so what we need to do, we need to combine about two figures, say of one of beam mechanism and one of sway mechanism. Okay, so now see, this one is, first of all, just a minute, see, this one is the sway mechanism, while this one is my beam mechanism, like this. Okay, so we have just combined two figures. Now in case of the combined mechanism, there are certain rules for occurrence of the plastic hinge. So first rule, say plastic hinge will produce, say talking about this left leg, see in the left leg plastic hinge will be produced only at one point, either we can say at over here or over here. Say it cannot produce at this both ends, it will be produced only at one end. This rule is applicable for the left hand side leg of the frame only, okay. Then second, it will be produced at this one, at the center, which we always take in the theta, in the beam. Then it will produce over here also in the beam, right hand side corner of the beam, okay. Then talking about frame, then it will produce at this one also for the frame mechanism, and over here if it is a fixed support, then it will produce over here. Say at A and E, depends, a fixed support is there, then obviously plastic hinge will be formed, and if hinge support is there, then it will not produce over here. Okay, once again let me repeat the first rule, it will be produced either at A point or either at B point. It can never be produced at the both point, whether it is a fixed point or anywhere else. That we will carry out in the sum. Okay, so first of all, see, first of all, where the combined mechanism will be produced, first of all at A, because our original figure is like this, at A fixed support and over here hinge support. Okay, so A fixed support, B obviously no, we will not take B, as we have discussed, we are taking only one point on the left hand side leg, A. Then this central point, that is C, and then this point D, one of frame and as one of beam also. Okay, and at E, as it is a hinge support, so no plastic hinges will be produced. So plastic hinges will be produced at A, C and D. Now let's talk about external work done. So in case of external work done, what we have done earlier, we need to do the summation of that one. See, in the beam mechanism, external work done was like this, W into deflection, that is W into L by 2 theta. So see, W into L by 2 into theta. Then in frame mechanism, the external work done was WL theta. Just a minute. WL theta. Okay, so for the external work done, what we need to do, we need to do summation of external work done due to beam mechanism and external work done due to sway mechanism. So WL by 2 theta into WL theta, so ultimately I will get 3 by 2 WL theta. That's the first case, that's external work done. Talking about internal work done now, that will be carried out by, first of all, at A, moment will be produces, so MP into theta. I am not taking consider it as B, as I have already taken at A in the left leg. Then this one, MP into 2 theta. Okay, then this beam mechanism, MP into theta. Okay, and then this sway mechanism, MP into theta. This one. At E, no moment is there, so no mechanism will be there. So ultimately solving this one, 1 2 3 4 5, ultimately it will be 5 MP into theta. Okay, so 3 by 2L WL theta, and this one is 5 MP theta. Let's equal these two terms. So 3 by 2 WL theta equals to 5 MP theta. So by solving this term, I will get the W, that is 10 by 3 MP by L. So I can say 3.33 MP by L. So we have got three mechanisms, beam, sway and combine. So as we are going to calculate the load, so load will be taken as always as minimum load. So beam mechanism answer is 8 MP by L, then sway, that is 3 MP by L, and frame, that is 3.33. So ultimately minimum answer is obviously 3 MB by L. So collapse load equals to minimum load among all the loads. So answer is 3 MB by L. Okay, so this is the first example. Okay, so what we need to do, first of all we need to calculate this n, this one. So from this one we will get the numbers of independent mechanism, mostly it will come two. So one we need to do beam mechanism and another we need to do swing mechanism, and once you get two mechanism then we need to combine them both, that is known as combined mechanism. Okay, like that. Okay, let's solve another example. Now in this one, as you can see, example number 2, determine the plastic moment of resistance of the portal frame shown in figure. 7 marks, May 2017. Okay, now first of all again same thing, plastic hinges formation. So first of all, as it is a fixed support, so at A, B and C intermediate support, E location of point load, and D again fixed support. So it will produce at out the point A, B, C, D and E. See, so possible location of the plastic hinges are A, B, C, D and E. Now talking about numbers of independent mechanism, that is small n minus r. Small n, that is 5, we have already got the value, numbers of plastic hinges. Talking about r, so r means SI, numbers of reaction produces. As fixed about 3 reactions will be there. Similarly over here also same thing, 3 reactions will be there. So 3 plus 3, total reaction is 6, minus equilibrium conditions, that is numbers of equilibrium condition is, that is 3. Okay, so our answer is, we can say 2. Just a minute, let me zoom it. Over here one printing mistake is there. 3 plus 3 minus numbers of equilibrium condition, that is 3. So total 6 minus 3, our answer will be 3. So small r's value will be 3. Just a minute. Yeah, okay, so then capital N, that is small n minus r. Small n is, okay, it is a printing mistake, let me write over here, small n minus r. Small n, that is value of 5, and r, that is value of, this one is 3. Okay, so ultimately I will get the answer 2. Okay, this is the correction, remember this correction. Okay, now as we got the answer 2, as I told you in the previous example also, mostly we will get the answer 2 only. Okay, so as n is 2, so 2 mechanism will be produced, beam and swing. So first of all let's talk about the beam. Now in this one, just a minute. Now in this one is the beam mechanism and its moment is twice mp, remember this one. Okay, central point load is there. So let's do the beam mechanism. So first one, this one, central point load. Okay, theta will be equal, as the central point load is there. Talking about deflection, this one, so it will be, let's take any of the triangle, say tan theta equals to this deflection divided by span, that is this one, 3 meter. So deflection equals to, we can say 3 tan theta. Say tan is very small, so deflection equals to 3 into theta. Okay, so external work done, load into deflection, W into delta, that is 20 into 3 theta. We will get the answer 60 into theta. That's the first. Now talking about the internal work done. So for internal work done, as we can see, say this one is our beam, just a minute, B and C. So these both are intermediate support. So at intermediate support moment will be produces, and the moment is given to us, that is twice mp. So at both B and C twice mp will be produces, as well as at the center also twice mp will be produces at the location of the load. Okay, now theta and this one is theta plus theta, that is twice theta. Okay, so talking about internal work done, first of all this twice mp into theta, then this one twice mp into 2 theta, then twice mp into theta, this one. So ultimately we will get the answer, this one is 4 plus 2 plus 2, total 8 mp into theta. Now by the principle of the virtual work, external equals to internal. External is 60 theta, internal is 8 mp theta. So 60 theta equals to 8 mp into theta. theta theta will be cancelled, and MP equals to 7.5 kilonewton into meter. Okay, that is this one. Now talking about frame, so as we discussed in the previous example, because of this force ultimately vertical leg will deflect like this, so ultimately frame will become like this. So this will be the figure of, we can say, sway mechanism. This one is W, while this will be as a deflection. Okay, let's see. Like this. Okay, this one is our load, this one will be our deflection. Okay, so talking about the moment, first of all, as both are fixed support A, B, C, D, so moment will be produced at each support, at A as well as at D. Now at B and C intermediate support, obviously moment will produce at that point only. Okay, so ultimately plastic hinges will produce at each and every point A, B, C and D. Now talking about the deflection, say we need to consider this theta, just a minute, this triangle, this one is our theta, so tan theta equals to, say this one is our deflection, say deflection divided by this span is how much, I think 4.5 meter, yeah, 4.5. so ultimately delta equals to 4.5 into tan theta, so tan is very small, so delta equals to 4.5 into theta. Clear? So I got this answer. So finally, external work done, load into this deflection, load is W, deflection is delta, load is 6 kilonewton, deflection is 4.5 theta, I will get the answer 27 into theta. Now talking about internal work done, as I told you, at both are fixed support, so first one MP into theta, then intermediate support MP into theta, then this intermediate support MP into theta, plus this and fixed support, that is MP into theta, so ultimately 4 MP into theta. Clear? By the principle of the virtual work, external equals to internal, 27 theta equals to 4 MP theta, so ultimately MP equals to 6.75 kilonewton into meter. So we got both, say, beam mechanism as well as sway mechanism. Now let's solve the combined mechanism. Now what we need to do, in sway mechanism we need to put down the beam mechanism like this. Okay, so see, this one was our sway mechanism, just a minute. Okay, now in this one we have put down this beam. Okay, so this will be our figure. Now talking about the plastic hinge, so let me do the figure over here. Fixed support, fixed support. So first of all, over here fixed support, so I have taken the left leg location, then I will consider it as a center, then I will consider it as a beam, then I will consider it at a frame, and over here moment will be produced because of fixed support. So ultimately plastic hinges will be produced at A, at E, then at C and at D. See, A, E, C and D, this one. So plastic hinges will be produced at this 4 point. Talking about the external work done, so we can say external work done equals to external work done due to beam plus external work done due to sway. Okay, so we can say for beam mechanism external work done was, just a minute, 16 to theta, and for sway it was 27 into theta. Okay, see, 16 into theta, 27 into theta, so ultimately 87 into theta. Talking about internal, so internal work done. Now for internal work done, in the frame moment is MP, while in the beam moment is twice MP. Remember this one. First of all, for the vertical leg fixed support MP into theta, then for the beam twice MP, for the beam it is a twice MP, so twice MP into 2 theta, then over this point, now this point is the common between these two. Okay, so over here in the beam mechanism it is twice MP, while in the frame it is MP. So I have told you earlier also in the beam portion, okay, whenever at the common point we are getting two different MPs, Okay, so always consider it as a minimum. So I will consider it as a minimum. So mp into theta for this. So first one was this, second one was this, and third this mp into this theta, beam portion. Clear? Fourth, this mp into frame theta, that is this, and last one this mp into theta for the fixed support. Okay, so this moment will be produces. By simplifying this term, I will get 8 mp into theta. Now, by the principle of the virtual work, we know that external equals to internal. External is 87 theta, internal 8 mp into theta. So by solving this sum, I will get the mp, that is 10.88 kilonewton into meter. Okay, so finally plastic moment equals to maximum among all the moments. So we have got, just let me see, first one was 7.5, second was 6.75, and 10.88. Obviously maximum is 10.88, so final our maximum answer is 10.88 kilonewton into meter. Okay, so guys, these were the examples of the portal frame of the plastic design method. Okay, thank you.